Hi everyone. Today's lesson is 2-4, and we're going to focus on adding and subtracting rational expressions. Yesterday we multiplied, divide, and simplified rational expressions, but today we're going to be looking at adding and subtracting, which everyone knows when you add and subtract fractions, you must first find a common denominator. That's a big part of what we're doing. Let's go ahead and jump right on in. The first problem, the directions state, simplify each rational expression. The first fraction, 2x minus 5 over 6, plus the quantity of x plus 1 over 8. In order to combine these, we need to have a common denominator. Our 6 and our 8 both need to go into the same number. What would that least common denominator be? In this case, 24. Right? We know 6 and 8 both go into 24. So we need to turn these fractions into fractions with denominators of 24. In order to do that, we just need to multiply 6 times 4, but if we do the bottom of the fraction times 4, we have to do the top to keep it proportional. What we have right now then is 4 times the quantity of 2x minus 5 all over 24. And our fraction on the right, to turn 8 into 24, we're going to have to multiply it by a 3, which means we also have to multiply the numerator by a 3. Remember, 3/3 and 4/4 both are the same thing as 1. So we're just changing what our fraction looks like, not changing its value. This would be 3 times the quantity of x plus 1. Now we can rewrite it as one fraction. While I'm doing it, I'm going to simplify at the same time. I'm going to distribute my 4 through to get 8x minus 20. And since this is plus, this makes it easier on me. I can say plus 3x and plus 3. And right now it's all over 24. Let's combine the like terms. 8x plus 3x is going to give me 11x. And then negative 20 plus 3 is going to be negative 17. And that's all over 24. We'll look to see if this factors, and it doesn't. But if it did, we can maybe try to reduce it more. But it doesn't always happen. 11x minus 17 all over 24. Look at the next example. T plus 2 all over t plus 3 over t to the third. With this one, our denominators are just monomials, and t is actually a factor of t to the third, so we're only going to need to manipulate one of the fractions to get the common denominator. Let's take this t on the left, and if we multiply it times a t squared, we'll get t to the third, which should be their common denominator. But again, if we do it on the bottom, we must also do it on the top. So what we're looking at here is t squared times the quantity of t plus 2. And then we have plus 3. And right now it should all be over the same denominator, which would be t to the third power. So I didn't show as many steps on that part of it because, this one's a little bit easier with the monomial, but you need to show whatever you need to show to make sure that you're getting it correct. Next step here, let's go ahead and simplify our numerator. Let's distribute that t squared through. Now we have t to the third plus 2t squared plus 3 all over t to the third. As tempting as it is, remember, you cannot cancel out these t to the thirds because this t to the third is being added to all of this. It's got to be the same factor. So in this case, we look and say, does the numerator factor at all? It does not, and since it doesn't, this is our answer. T to the third plus 2t squared plus 3, all divided by t to the third. Next problem. I have an x plus 2 over an x minus 1, and we're subtracting an x over an x plus 1. Now, x minus 1 and x plus 1 in our denominators, these are not the same thing. These are different. Okay, and I can't add anything to make them the same. So don't try to add 2 to the denominator on the left. It doesn't work the same way. We have to multiply it by something to get a common denominator. Well, if each of these is just a different factor, then we can get a common factor by multiplying the x minus 1 by an x plus 1. But if we do it to the bottom, we got to do it to the top. Now my fraction on the left will have x plus 1 and x minus 1. And I need my fraction on the right to have the same denominators, so I need to multiply it by whatever the other side has that it does not. It should be an x minus 1. If I do it on the bottom, I'm also going to do it on the top. And now we're going to look at what we've got. So remember, we're going to be doing this times this. So x plus 1 times the quantity of x plus 2. And that right now is all over an x plus 1 times an x minus 1. We're subtracting an x times the quantity of x minus 1 over that same denominator. So same denominator. This means, and this is always a mistake that's made, so please make sure you're listening. If you fell asleep, wake back up. Let's do this, okay? Please do not try to cancel these out. You cannot do that. That would be very bad. Don't do that. If you try to cancel things out now, and somebody will try to do this, you no longer have a common denominator. Okay, so let's erase the bad, and let's do what we need to do. The reason we've got the two common denominators is so that we can combine it into one fraction, right? We have the x plus 1 times the quantity of x plus 2 minus the x times the quantity of x minus 1 all over just the single x plus 1 times x minus 1. Now just simplify your numerator. So you're going to have to FOIL all of this. You're going to have to distribute this x through and then combine your like terms. That will look like this, x squared plus 3x plus 2. And then this is going to be like an x squared minus x, but you're going to be subtracting it. So you're going to have to distribute that through and get a negative x squared plus x. If we go ahead here and let's just put little quotation marks there, show that our denominator hasn't changed. Let's combine our like terms in the top. So x squared and negative x squared cancel out. This x and this 3x gives me 4x. And then I add 2, 4x plus 2 over x plus 1 times the quantity of x minus 1. Our numerator does factor, but when we factor it, we get 2 times the quantity of 2x plus 1, which would not cancel out with anything on the bottom, so don't worry about factoring it. This will be our answer. Okay, now, I maybe showed more work than what you wanted to show. Sometimes you need to show more work. You know, it varies a little bit. I'll give you a little room, but I shouldn't see this problem at the top and then this answer there with nothing else shown. The next problem, 3b over b minus 5 plus 15 over 5 minus b. Let's pay close attention to our denominators. How would you describe these? They're opposites. So I could turn this denominator on the right into the same denominator by factoring out a negative 1. And now I have negative 1 times the quantity of b minus 5 in the bottom. And on the left side, I have my 3b over b minus 5 in the bottom. So the only thing that's different is this one is negative. But let's just take this, and if I'm adding a negative, isn't that the same thing as subtracting? 3b over b minus 5 minus 15 over b minus 5. Now they're the exact same denominator, and we can combine it into one fraction. 3b minus 15 over b minus 5. And just like I asked you in the previous problem, does the numerator factor? In this case it does. We factor out the greatest common factor 3, and we have b minus 5 left over. And that's the reason we want to factor it there before the end, because now you'll see that we can factor out that common factor, and our answer we're left with is just 3. Okay, let's move on. Now we've got an example where we're going to have to factor our denominator a little bit more so that we can see which factors are missing so we can get our common denominator. So c plus 1 over c squared plus 3c, and then we're adding a c plus 4 over 3c plus 9. First step, factor your denominator. I'm going to take out my greatest common factor. I have c times the quantity of c plus 3. Right now we still have a c plus 1 on the top, plus our greatest common factor is 3, so we have 3 times the quantity of c plus 3, and then a c plus 4. Both of these have a c plus 3, but my right fraction has the 3 and my left fraction has the c. So we need to have the same factors in each of our denominators to get the common denominator. We're going to multiply this side by a 3 over 3, and we're going to multiply this side by a c over a c, so our denominators will match up. We'll have a 3c times the quantity of c plus 3 in our denominator. In our numerator, what we're looking at is 3 times the quantity of c plus 1 plus c times the quantity of c plus 4. Simplify your numerator. Go ahead and distribute. I have a 3c plus 3 plus a c squared plus 4c. And right now it's still all over the same denominator. Let's simplify. That's going to give us c squared plus 7c plus 3 over 3c times the quantity of c plus 3. As we look at that, I don't believe that our numerator factors at all, so we won't be able to cancel anything out, and this is our answer for that problem. C squared plus 7c plus 3 over 3c times the quantity of c plus 3. A lot of talking, good lord. All right, we're almost done. Let's keep going. We've got 6 over x squared minus 7x plus 12. First thing, let's go ahead and factor. Let's pick up the pace a little bit here. We've got x minus 3 times the quantity of x minus 4, plus on this side, we factor into x minus 3 times x plus 1. We still have our 5x plus 9 in the top. We look at our denominators. They both have an x minus 3. This one has an x minus 4, but this one has an x plus 1. I need that x plus 1 on the left side, so I'm going to multiply the top and the bottom by the x plus 1. So I have 6 times the quantity of x plus 1. And then my other fraction, I need the x minus 4. So when we do that, we have plus the quantity of 5x plus 9 times the quantity of x minus 4. And it's all over x plus 1 times the quantity of x minus 3 times the quantity of x minus 4. Simplify. Let's distribute 6x plus 6 plus, let's distribute this through. We have 5x squared minus 20x plus 9x, and then we have minus 36. Combine our like terms here. Let's see what we got. Right now it's all over the same denominator, but looks like I have a 5x squared. In terms of my x's, I have a negative 5x. And for my constant terms, it looks like I have a negative 30. Still all over x plus 1 times x minus 3 times x minus 4. My question is, are you finished? How many of you have tried to factor that numerator? It actually does factor. Our greatest common factor is 5. And when we factor it out, we have x squared minus x minus 6 left over, which actually factors a little bit more. We have 5 times the quantity of x minus 3 times x plus 2. And that is over our quantity of x plus 1 times our quantity of x minus 3 times our quantity of x minus 4. And you'll see now we can simplify just a little bit. And our answer will be 5 times the quantity of x plus 2 over x plus 1 times the quantity of x minus 4. All right, so I think this is the last one, and we'll try to get through as quickly as we can. This one can be a little tricky, so I want you to make sure you're paying attention. Remember, this one is different than if you had, say, x plus 1 plus the quantity of 3 over x plus 2. These are different. What we actually have is three things. We have an x over a 1 plus a 1 over a 1 plus a 3 over an x plus 2. Now, if you're looking for a common denominator, it looks like it would have to be an x plus 2. So we need to get an x plus 2 in the denominator of each of these. Well, we already know that 3 over x plus 2 is going to not change, but I'm going to need to multiply the denominator here by an x plus 2, and then also the numerator. And my middle term, the 1, I'm going to have to multiply it by x plus 2 over an x plus 2. And now let's fill in what we have. So I'd have an x times the quantity of x plus 2 plus 1 times the quantity of x plus 2 would be another x plus 2. And then we have plus 3 over x plus 2. Let's go ahead and combine it into one fraction and simplify. I'm going to go ahead and distribute this through. So I have x squared plus 2x plus my x plus 2 plus my 3. And it's all over x plus 2 right now. And let's combine our like terms. X squared plus 3x plus 5 over x plus 2. And at that point there, it doesn't look like we can factor the numerator, so there's no chance to cancel out the denominator. This would be our final answer. X squared plus 3x plus 5 over x plus 2.